a Math-2. So we're going to do assignment number 2 solutions here. Now, all of these ones we could solve algebraically, and we did solve algebraically in the previous question. Now we're just going to solve them graphically. Usually you do this way if you can't change the base. That's fine. So what I'm going to do here is I'm going to put in the y1. I'm going to put y, this happened last time. Okay. I'm going to put y1 is x plus, or 2 to the power of x plus 1, and then y2 being 16, and then find out where they cross each other. So I have just quickly type these in. So you can see here, and I'll put a 16, and then I'm going to go zoom standard just to start off. Now the zoom standard is not going to fit that 16 line. Remember, y16 is a line that's horizontal at 16, but this graph only goes as high as 10 right now. So we're going to go window, change the y maximum to be at least 16. So I can at least see that line on the top. There it is there, right on the top. You can see where they cross each other. So as long as you can see where they cross each other, you're good. As long as they're within the domain too. It doesn't matter if they're within the range, but within the domain, then you can find the intersection point. So my intersection point here is going to be 3, 16, but the solution that I want is just 3. There you go. Okay, so that's just pretty much the way it is for all of these. So this one here, I'm going to have a 9 to the power of 2x, and then I have a 27. Now again, I'm going to graph this. Then you're going to realize that you can't see the 27 because the 27 is well beyond the graph. So I'm going to go to window. I'm going to go my y max and at least make that 27. I'm just going to make it 28 a little bit higher. At least I can see the intersection there. So go second trace 5, enter, enter, enter. You don't have to see it very nicely, because you just have to see it. So 0.75, comma, 27. That's weird, comma there. Let's fix that up a little bit nicer. There you go. Some of the answer for just for the x here is going to be 0.75. Okay, my last one here, pretty easy. Plug that in my calculator. X minus 1, 25 to the power of x plus 4. Nothing else weird about that. Okay, I'm going to just go back to my zoom standard. There's my 2 graphs. I don't know where they cross. Maybe they actually cross each other already. They're not going to cross. Yeah, maybe they do. I don't know. So what I'm going to do is I'm going to second trace 5, enter, enter, enter. Hey, look at it. The intersection is there. Remember, if it's not within the domain, it's going to give you a no sign change. So you're going to have to expand the domain out. It's hard to see where they would have crossed here, but they do cross. When this is equal to -9. And this number here is a really small number. It's like, if you were to put that in decimal, it would be 0.000001024. That's technically what that number is. That times that e to the -7 means times 10 to the -7. So it's really close to being 0. It's not 0. It never will be 0 because that's one of the restrictions of this. But the answer is just -9. That's all we really cared for anyway. Okay. Most of these are going to be solved graphically. So I'm going to solve most of these graphically. So I'm just going to leave my graphing calculator open here. So here a student deposits a certain amount of money. So I'm just going to plug that in there. So it looks like they deposited $1,575. And the money is increasing by a specific amount each t interval. Okay, so I'm assuming the t interval is it time, years, t is in years. Okay, so the initial amount of money that this person put in the money or bank account is $1,575 because that's the when t was equal to 0, which is the y-intercept, right? So that's going to be useful. Determine the initial interest rate being paid, annual interest rate being paid on this account. Well, that's going to be the B value. Since the B value is 1.045, That's the same as 104.5%. So what I'm going to do is I'm going to take 100 out from that to get 4.5%. Okay, so there you go. Not bad so far. Use the equation to find the money to the nearest dollar after 15 years. So it says use the equation. I guess that you could use the equation in the graph as well, but you just put down 15 years here, right? And then you go to your graph here, or not, you don't have to go to my graph. So 1575, 1.045 to the power of 15. I think it says 15 years, right? Yeah, after 15 years. So after 15 years, oh, he's got double his money pretty much. To the nearest dollar, so that's just no decimals there. How many years will it take for the account to have $4,000 in it? So you could just keep on just guess checking, revising. So the nearest whole year, so you could be like, oh, okay, so let's just change this to 17 and see what happens. Oh, not enough, right? You keep on doing that if you wanted to. Seems like a lot of work. So I'm going to go to my graph. Okay, the problem is I'm going to my graph. I've got to go to my window. The reason you don't see anything, remember your y-intercept is really high. It's at 1575. So you're going to go to your window. Make your y max bigger. I'm going to go 2,000 for now. Looking pretty good. Actually, I want to know when it's equal to 4,000. So I'm going to my window. 4,000. At least 4,000 up there. Look at that. Okay. Now, if I were to put a line there at 4,000, you're going to see that line, that $4,000 line. You notice that they don't intersect over here. If I try to intersect, it's going to cause some problems. So I got to make my X max a little bit longer. I know it's got to be more than 15. So let's put down 20. The reason I know it's more than 15 because 15 is only $3,000. 20, maybe? Oh, I don't think so. Not quite. Okay, let's go a little bit more. So let's go 25. Perfect. Second trace 5, enter, enter, enter. So it's going to take 21 years. Oh, actually, 21 years may not be enough. It's going to take 22 years. And the reason I rounded this up, we went from 21.1 years to 22 years, because 21 is not going to have enough money. So I can double check that too. So if I go back out of this, and I go to that equation that I was playing around with there. Now to do that, I'm going second enter. It just pulls the previous equation up. And I'm going to change this to 21. Notice 21 is not going to have enough money. It's really close. All right, so I want $4,000, but this is only $3,969. So 22 gives me the $4,000 I need. So I'm not going to round it down here. I've got to round it up. Otherwise, I'm not going to have enough money. Okay. Here we're going to do an exponential regression. Just find the equation every 10 years. Doesn't specify anything about changing those numbers. I'm going to leave the numbers the way it is because it makes it easier to type in like 1985. Like, excuse me, just type in 1985. Okay, so I'm going to clear out my list first because I know I have some previous regressions in there. So I'm going to go second mem, like I did there, second mem, number 4, clear all this. Hit enter again so you get done. So go to stat, edit. I'm going to type in my numbers here. So I've got 1950, 1960. You could put 0, 10, 20, 30, 40, 50, 60. It'll give you a better equation. It won't change your answers, though. Actually, I don't know if we will change your answers. I just like doing it this way. It's easy to type it in, like I said. Population. Is it something weird about this population? No, that's just the population it is. Okay. I'm in the wrong place to type my numbers. That's what I do. Back to my calculator here. Perfect. Hope you like my quarantine mustache today. You guys should use this. It's just a Snapchat filter, but it's a program for the computer. It's fun, you know. I mix it up. Oh yeah, sorry. I was thinking, where's my last number? It's over here. Okay. 6465439. Okay, so hopefully I punched those numbers in correctly. If I didn't punch those numbers correctly, I'm going to get something slightly different than yours. I'm going to go y is equal to. Oh, I got some stuff here. Let's get rid of those. So just hit the clear on each line. Go to plot, and then we're going to go zoom number 9. So there's my line. So it looks pretty good, actually. Looks like it's increasing a little bit as it goes. So I'm going to go stat, calc. We're in exponential, so I'm going to exponential regression this. I'm going to store my equation. Bam, there it is. Looking pretty good. That's the equation. Okay, so I get P, because they want a P here instead of Y. Oh, I'm just going to put my cup. There we go, that's better, okay. They got P, then A is going to be 3.40 times 10 to the negative 12. It's a really small number. Just because it's going back to like year 0. I would have very close to having 0 people at year 0, wherever this place is. Doesn't make any too much sense though. But my B value makes sense. I'm increasing by at least 2%. Yeah, I'm going to put a 2 here every year. Okay. Put a T rather than an X because that's what it says here. There's a little T and there's a little P. Calculate the population to the nearest whole number at 1985. Does this calculate that? So technically what you could do put in 1985 up here. Punch that in. I'm not going to do that. I'm just going to go right to my graph here. There's my graph. I'm going to go trace and type in 1985. So make sure you're on the right line. So I hit the up and down arrow to make sure this is Y1 here. Because otherwise hit trace, you're just going to kind of bump you out a little bit. But here it says 398,885 people. Nice. Assuming the population grows, what year will you have 1 million people? So I'm going to go to window. Million would be on my Y max here. So I'm going to put 1 million right there. Cool. Graph that. Okay, I'm going to go Y is equal to, I'm going to put 1 million line there because 1 million would be here. It's on the other side of the equation, right? Is equal to this equation. Never check for time. So I'm going to put Y1 on this side, Y2 on this side, and find out where they intersect each other. I think I have enough zeros there. No, I need one more 0. Graph that again, so you notice I have the line there, but they don't intersect. So if I try to find the intersection point, it's not going to work. I'm going to have to change my window past 2016 here. I don't know, when do you think this will be? 2030? Let's double check. Oh, that was a bad guess, 2030. I don't think that intersects there. There's a little gap there, so I'm just going to change this to maybe 2035 instead. A little bit higher. Perfect. Second trace 5, enter, 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 and we get an intersection point of the year 2031. Cool. Pretty good. Okay, so this one here says find the area in find the area, the shaded area in image 4. So there's a pattern here. Okay, so we have to follow the pattern. So in image 1, the area is 0. In image 2, the area that's shaded is half. In area 3, the image is shaded is a half plus a quarter. You can see that. So this is a half plus a quarter, because this was 0 plus a quarter. This is 0 plus a half plus a quarter. And then I'm going to go one more. I'm going to go 0 plus a half plus a quarter. Now the reason I know it's a quarter, because this is the half right here. That's the half. And the quarter is that this is a half of a half, right? Because this is a half, and well, the two circles put together is a half, and those are just half of a half. Half of a half is a quarter. Okay, so what's the next one's going to be here is that these pieces are a quarter. So if I add all those pieces together, that's a quarter of this, but then I'm only shading a half of that quarter. So this extra little piece is going to be an eighth. So that's the shaded area here. So 1 plus a quarter plus an eighth plus or plus a quarter plus an eighth. Got a lot of things here. Oh, I just pull out my calculator, just punching in numbers. So I got 0, I got a half, and then what do I get for the next one here? I'm just staring at my calculator. I don't know what I'm doing. Okay, 0.5 plus quarter, so I get 0.75, which makes sense. That's 3 quarters. And I'm going to add an eighth to that, and I get 7/8. Cool. I wonder if there's a pattern. I think the next one will be 16ths, like 15/16. Maybe. If the pattern were to continue, what would the area of the shaded region be for image 10? Okay. So for image 5, I'm just going to write this down. Image 5, I would have 0 plus a half plus a quarter plus an eighth plus a 16th. So I'm going to add in a 16th to this. Oh, that didn't work well. Plus a 16th. My number, math enter. Yeah, you get 15/16. Looking pretty good. I'm going to assume like my next one's going to be 31 30-seconds. It's like I'm timesing the bottom number by 2 each time. And the top numbers always has to be 1 less than the bottom number. Like this would be over 1. So it'll be 1 less. So I'm going to be adding a 30-second to this, plus 1 over 30-second. Math enter. Yeah. You get, oops, sorry. I get 31 30-seconds. Okay. That's image 6. 7, 8, 9, 10. Okay, so I'm not too concerned about the top number until I get to 10 here. So I'm going to take 32 times 2, so I get 64, which makes the top number 63 on that one. Times 2 again, I get 128, 127. Times by 2 again, I get 256, I get 255. And times it by 2 one more time, I get 512. So how much is that? It's a considerable amount of it, actually. It's like 99.9 or 99.8% of that box will be shaded. Because it goes 50%, 75%, 80-some%, and it gets bigger and bigger as you go. And the last little bit. No, I'm going to just write some stuff down here. So the bottom number looks like I'm just timesing by 2 the bottom number each time. All right, and the top number is always 1 less. 1 less, right? It always just seems to be that way. 1 less. one less. So I saw a pattern and I used it. Sounds pretty good. Hopefully that helped you out, and I'll see you in the new.